Hello everyone, how to solve this problem for the values of k if we have k times of square root of k is equals to 27 and we solve this problem for all the values of k. So here first we need to find all the roots of this equation, and at the last we will be verify that which of the roots are solution and which of the roots are extraneous root. Further, here we move toward the solution of this problem. Now here very first thing we are going to do is first we need to remove this square root sign from left hand side. So in order to remove this square root sign, we need to take squaring on both of the sides, so that when we apply squaring on both of the sides, it will be written as in this form. This is 27 and its whole square. And now here we use the nice property of square, and in this property, if you have a multiplied by b and its whole square, so we apply the square separately on both of these two values. Okay, so we write it as a square minus a square multiplied by b square. Okay, according to this property of square, here we apply this separately on both of these two values, and it will be written as k square is multiplied by square root of k and its whole square is equals to, here you see that this is 27 and we need to find the prime factors of 27, and you know about that the prime factors of 27 are 3 cubed and its whole square. So here we use another nice exponential rule. You know about that. If we have a to the power of m to the power of n is equals to a to the power of n to the power of m, it means that if you interchange both of these two exponents, this will be always gives us the same answer, and it is equals to a to the power of m multiplied by n. So further in the next step we have, this is our k square, and here this 2 and this square root are cancelled out by each other, and we will get here k only is equals to, and in the right hand side now we need to interchange both of these two exponents. So when we interchange these two exponents according to this rule, it will be written as 3 square and its whole cubed. And now here further in the next step we need more simplifications, and it will be written as this is k square multiplied by k is equals to k cubed. This 3 square becomes here 9 and its whole cubed. So here we need to move this 9 cubed from right hand side to the left hand side, and it will be written as k cubed is equals to minus 9 cubed, and this whole equation is equals to 0. And here we need more simplifications, and now here we apply the nice cubic formula. You know about that. If we have a cubed minus b cubed is equals to a minus b times of a square plus ab plus b square. According to this rule or this nice cubic formula, we write our above equation as this. Here we have this is a minus b, the value of a is k minus the value of b is 9 into this is a square, the value of a is k square plus ab, the value of a is k and b is 9 plus this is b square and our b is 9 square, and this whole equation is equals to 0. And now here further in the next step we need to divide this equation into the two cases. The first case is we write k minus 9 equals to 0, and the second case is we write k square plus this is 9k plus this 9 square becomes 81, and this whole equation is equals to 0. So from here we easily get the value of k is equals to 9. So this is the one real root of the given equation, and now here in order to find the other roots we need to solve this quadratic equation. So in order to solve this quadratic equation, here we apply the quadratic formula, but you know about that there are three methods to solve the quadratic equation. The first method is factorization method, second one is completing square method, and third one is by applying the quadratic formula. But here I like the quadratic formula to solve this problem. So for this we need to write the coefficients of this equation, and its coefficients are a is equals to 1, b is equals to 9, and c is equals to 81. And we state the quadratic formula as k is equals to minus b plus minus square root of b square minus 4 times of ac divided by 2 times of a. So this is the our quadratic formula, and here we need to substitute the values of a, b and c, and when we put these values here, it will becomes minus 9 plus minus square root of b square. So b is 9 square minus 4 times of a is 1 and c is 81, and it is divided by 2 times of a, and here our a is equals to 1. So here we need more simplifications in order to get the values of k, so that we have this is minus 9 plus minus square root of 9 square, and 9 square becomes 81 minus, here we write these terms as it is, this is 4 multiplied by 81, and it is divided by 2 times of 1, and 2 times of 1 is equals to 2. So here further in the next step we need more simplifications, and it will be written as this is minus 9 plus minus square root of, here you see that 81 is lies on both of these two terms inside the square root sign, so that we will take common 81 from here, and when we take common 81 we get 1 only, and when we take common 81 from here we get 4 only, and it is divided by 2. So further in the next step we need to apply the square root sign separately on both of these two values, and it will be written as minus 9 plus minus, this is square root of 81 into square root of 1 minus 4 becomes minus 3, and it is divided by 2. And here further in the next step we need more simplifications, and it will be written as minus 9 plus minus, here we know about that square root of 81 is equals to 9, and here we apply square root on 3 and square root on minus 1, and you know about that square root of minus 1 becomes here iota, and it is divided by 2. So here finally we have, these are the other two complex roots of the given equation, and here we will get there are three roots of the given equation. The third root is k is equals to 9. So these are the final three roots of the given equation, and this is the final answer. Thank you so much for watching this video. Please subscribe to my channel for more exciting videos.